Hi, everyone. Welcome to lesson 1.4. Today, we're going to review graphing linear functions. So hopefully you remember from your coursework last year that there are three methods to graphing linear relations. And one is using a table of values, one is using x and y intercepts, and one is using slope-intercept form. So let's take a look at all three, and hopefully the review goes smoothly. So let's take a look at the first example I have here, graph the following linear relation using a table of values. So we have the relation, the function given here is y equals 3x minus 1. And so we enter, here we'll enter 5 x values, input values. And I usually like to do a couple of negative ones and then a couple of positive. So I'll do -2, -1, 0, 1, and 2. And recall what you do with these x values is we plug them into the x value in the function and then just evaluate what that is. So 3 times -2 will give me -6. If I minus a 1, I'll get -7. 3 times -1 is -3 minus 1. That should be -4. If I have 0, 3 times 0 is 0, minus 1. If I use 1, I'll have 3 times 1, which is 3, minus 1 should be 0, and then enter the 2. 2 times 3 is 6. 6 minus 1 is 5. So let's go ahead and plot these points on the graph. Try and zoom in here as much as I can. So -2, -7 puts me right down there. And -1, -4. We have 0, -1. And then 1, that point looks like it's off. Let's do 2 and 5. So let's double check this 1 value. 3 times 1 is 3 minus, yes. So that should be a 2. And this should be 2. So we correct that, and let's go up here. So now that we have our lines drawn, let's do my best here to put in a straight line. And there we go. So let's move on to the next one. Again, we'll use a table of values, and I like to use some negative values, -2, -1, 0, 1, and 2. And we'll plug them into our function, y equals x minus 5. So -2 minus 5 is going to be -7. -1 minus 5 is -6. 0 minus 5 is -5. And 1 minus 5 is -4. 2 minus 5 is -3. Then we go ahead and plot those coordinates. So -2, -7, -1, -6, 0, -5, 1, -4, and 2, -3. So there we go with this. And there's my linear function on the graph. So that's using a table of values. Now let's take a look at graphing linear relations using the x and y intercepts. So recalling that if we want to find the x-intercept of a function, we have to set y equal to 0. So if I sub that in, I'll get 2x plus 4 times 0 equals 8. Simplifying, 4 times 0 is 0, so we are left with 2x equals 8 and x equals 4. So that's our x-intercept. So we can go to our graph, and on the x-axis, we plot a point at 4. Let's go and check out our y-intercept, and on our y-intercept, x equals 0. So we'll plug that into our function. We'll have, sorry, it's not 3, it's 2. 2 times 0 plus 4y equals 8. 4y equals 8. And so y equals 2. I go to my graph and I plot that intercept. We really only need 2 points to form a line. So between these 2 points, I will draw my line. A little bit off, but I'm drawing on the iPad. So anyway, let's move on to our next example. We have another function of 3x minus 2y equals negative 12. We want to find the x-intercept, so we'll set y equal to 0, and we'll have 3x minus 2 times 0 equals negative 12. Then we'll have 3x equals negative 12, and dividing out the 3, we have x equals negative 4. So on our graph, I put a point at negative 4 on the x-axis. To find our y-intercept, we'll set x equal to 0, and we'll have 3 times 0 minus 2y equals negative 12. Simplify that here, and I have negative 2y equals negative 12. Divide out by negative 2, and y is equal to 6. So I'll go back to my graph, and I will plot 6 on the y-axis, here and here. Once I have the 2 points, I can connect them by a line, and that's my linear function. Okay, good. So now we've taken a look at graphing with the table of values and graphing with intercepts. And we'll go back to our slope-intercept form. So remember, this is in the form y equals mx plus b, where b is your y-intercept and m is your slope. So let's take a look at this first example. We can identify parts of this function. So the slope here is 3, and the y-intercept b is 4. Remember, slope on a graph is equal to the rise over the run. And if we have a whole number like this, we can just create a fraction of 3 over 1, and it doesn't change the value. So to graph using this, we always start at the y-intercept and we plot that first. So on the y-axis, I'll put a point at 4. And then my rise and my run, I always count from this point, from the y-intercept. So I'll rise 1, 2, 3, and over 1. So pretty close to the top of the graph. So let me go down 1, 2, 3 over 1. There. And then I will connect my points with a line. This last example, slope here is negative 2 over 3. That is the rise, and 3 is the run, and my intercept is negative 1. So I always start with my intercept. I'll put my point at negative 1. And because my rise is negative 2, I'm going to go down 2 and always to the right. 1, 2, 3, and plot another point. Now you may want to do it one more time just to give yourself 3 points. Go down 2 over 3, and we can graph this line. Okay. All right. So in example 4, I give you 2 more linear relations, and I'm hoping that just by looking at them, you will decide what method is best. Typically, we don't want to use a table of value method to graph linear relations. At this point, it just takes too long. So if I have any relation in this format, I'm probably going to use the x and y intercepts. And then obviously over here, I have slope-intercept form, so we're going to use the slope and the intercept to graph. So slope, intercept, form. All right, so let's find the x-intercept here. We'll set y equal to 0 of 3x minus 4 times 0 equals 12. 3x equals 12. Divide out the 3, x equals 4, so that's my x-intercept. We will find the y-intercept by setting x equal to 0. So 3 times 0 minus 4y equals 12. Minus 4y equals 12. And dividing out that negative, 4y equals negative 3. So let's go ahead and put those intercepts onto our graph, x at 4 and y at negative 3. So we have 2 points, put a line through them. Oh, that doesn't look good. Let's try that again. X at 4, y is at negative 3. And let me be a little careful. There you go. And we'll do one last example together in slope-intercept form. So here my slope is 1 over 2. My y-intercept, we call b, is negative 3. We always start with our y-intercept, negative 3, and we count our slope, which is 1 over 2. So it's up 1 over 2, up 1 over 2, and we can start to see the formation of our line. Okay. So we're all done with reviewing quickly our linear functions. So go ahead and pull up your worksheet for this lesson and submit it when you're ready.